Question B says consider the number pattern -2, -5, -8, -11. Okay, and determine the nth term, hence the 145th term. So we look at the constant difference first. If there is a constant difference here, okay, I'll do -5 minus -2. Okay, so that's how we get the constant difference. You take a term, you minus by its previous term. So -5 minus -2. You can use a calculator if you're unsure. So -5 minus -2. Okay, and then this is equal to -3. And then see if that makes -3. Now let's see if -8 minus -5 is -3, is also -3. That's also -3. Then there is a constant difference here. So I can say Tn will be equal to -3n. Then I'll say to myself, if I have -2, I need to get -2. What can I do? You can do it somewhere there, like -3 plus what? You can call what x equal to -2. Now you move -3 on the other side. That makes x is equal to -2 plus 3, and x will be equal to 1. So that means over here you plus 1. Okay. That will be Tn. Now the 145th term will be T for the 5th, that means -3. N we're going to sub in here 145, 145, 145 plus 1. So this will be T145 will be equal to you can use -3 -3 multiplied by 145, okay, plus 1, and then this is equal to -434. So -434. Thank you. Well, now we're going to do consolidation and extensive exercises of number patterns, grade 10. Question A says, consider the number pattern given there. And now 1 says determine the nth term or enhance the 300th term, and then determine which term of the number pattern equals to 448. Now, let's start question 1. When I look at the patterns here, 7, 16, 25, I need to find first if there is a constant difference. Okay, I'll see here. How do I get it? I'll do 16 minus 7. Okay, 16 minus 7 is equal to 9. So we notice that it's 9. And then 25 minus 16 is also 9. 34 minus 16 is also 9. Because the pattern is common, note that here the terms are of the form dn plus c. Okay, well, D stands for the constant difference, and then C just the constant part. So here I'll say the nth term here, Tn, will be equal to what? 9, the difference, the constant difference is 9. I say 9n. And then to get this C here, I'll say to myself, if I have 9 here, this 9, how can I get 7 from 9 here? What operation can be plus or minus? Okay, I'll minus 2 to get 7. So I'll say minus 2. Okay, that's Tn. Now the 300th term will be means that wherever there is n, we'll substitute by 300. Okay, so I'll sub here by 300, T300, and then there also 300, and then we can do that even with the help of a calculator here. This will be use a calculator. Here it is. If I do 9 open bracket 300 close bracket minus 2, and then this is equal to 2698. Okay, and then question 2 says determine which term of of the number pattern equals to 448. So in this case, it means Tn now equal to 448. Okay, so Tn initially, okay, Tn, which is given by 9n minus 2, we write here, the value of Tn is 9n minus 2. We're going to equate it to 448. Then if you move, to solve this, we're going to move the -2 over, okay? So this will be 9n will be equal to 448 plus 2, which makes 450. Okay, to get the value of n, we divide by 9, and then we'll get here n will be equal to 50. That was question A. Well, we have question C, that is consider that diagram made up of black dots and joined by thin black lines. Now C1 says how many dots are there in figure 4. Okay, I'm gonna look at let's first write try to list the pattern of the dots. Okay, the pattern formed by the dots. If I look at figure, the patterns are 5 dots on the first 1, 2. If I count them, something like 1, 2, 3, 4, 5. There are 5 dots there on the first, and then the next one we add 3 dots, so that makes 8, and then the following will be 11 dots. Okay, so it's continuing like that. Now for the lines, we have 5 lines on the first, and the following also add another 5 lines, because check this one. Let me count the lines now. 1, 2, 3, 4, 5 on the first, and the following will be 1 here, 2 there, 3 there, 4 there, and then 5 again. So 5 dots again. So now, so the first is 5, the following is 10, and the other one is also 15, and so on and so forth. Okay. Now we can start answering the questions. Questions 1 says, how many dots are there in figure 4? Okay, if I say C1 in figure 4, the answer will be 14, because it add 3 all the times. Okay, we add 3 there, we add 3 there, so we need to add another 3 over here to get 14. Okay, and then question 2 says how many lines are there in figure 4? So the fact that we're adding 5 over here, so the fourth one will be 20. So we add, so it'll be 20. And then question 3, because we add 5, another 5 there, so it's gonna be 20. Question 3 says question 3 says how many dots are there in figure 8? So now over here, I don't need to work it out until I reach figure 8. Okay, I can just find the formula, write the formula for this. Over here, I can make Tn. I can see, because the constant difference is 3n, is 3, I'll write here 3n. Now ask myself, if I have 3, to get 5, the first term, what can I do? I can just add 2 to it. So it's gonna be 3n plus 2. Okay, same also here, Tn. I have 5 is the constant difference, so I'll write here 5n. Now if I have 5, I need to reach the first term, which is 5 here. What can I do? I add nothing to it. So I can then answer for the 8th term in question 3. I'll sub 8 there, so that makes that 3 times 8 is 24 plus 2 is 26. So it's going to be 26 dots. Okay, and then question 4, that is how many lines are there in the 8th, in figure 8. I'll do the same thing. I'll substitute 8 over here, and then that's going to be 5 times 8, which is 40. Okay. Then the following question is question 5 says determine the general rules to find the number of the dots. We already find it there in the previous question, so that's going to be Tn will be equal to 3n plus 2. And then 6 also says how many dots are there in 186 figure. So over here we will substitute, okay, 186 where we see n. So I can say Tn T186 will be equal to, I can use a calculator. So we say 3n, so 3 open bracket, and instead of n I write 186 close bracket, and then plus 2, which is equal to 560. So it makes 560. Question 7 says which figure will contain 272 dots. So it means I know that Tn is 3n plus 2. So which figure? So I'm looking for a certain figure Tn which will have 272 dots. So it's gonna be like 3n plus 2 equal to 272. So if I move the positive 2 over, I'll have like 3n will be equal to 272 minus 2, which is 270. Okay. If I move the positive 2 over, it becomes negative. In other words, minus 2, a minus 2 there. Then I have 3. Now to get the value of n, I will divide by 3 both sides. So like n equal to 90. So over here, I divide by 3. I divide also by 3, and then n will be 90. And on question 8 says, okay. I was saying question 8 says that determine the general rule to find the number of lines in figure n. We did find it already. We say that we found that Tn was equal to 5n. Okay. And then question 9 says how many lines are there in the line in the 900th. So over here we will substitute 900 over here. So if you do that, we'll get like 4,500 lines. And then that was question 9. And question 10 says which figure will contain 650 lines. So it means I want to say 5n equal to 650. So to do that, I will divide by 5. I divide also by 5 there, and then we'll get like n will be equal to 130 if we divide by 5. Okay. That was question C. Well, we have another question here, question D. The question says that consider the following designs. Okay, the design is here. And then question 1 says write down the number of squares in design 1, 2, 3, 4, and 5. All right. Now we can see that over here we have like 2 squares. And then over there are 3 2's, so that makes 6. And then over here there are 6 are here, and then plus 3, 9 plus 3, 12. So 12. And then here we already have 12, and then plus 4. That makes 16 plus 4, 20. 20. Then we can write it like they're like 2, 6, 12, 20. Now, to find the 5th one, we first want to look at if they have a constant difference. Let's see. If I look at the difference between the pattern, we note that here the difference is 4, okay, because 6 minus 2 is 4, 12 minus 6 is 6, 20 minus 12 is 8. Then they don't have a constant difference here. The first difference here is not constant. Now we must look at the second difference, okay? Now let's see the second difference. The second difference is constant. Because the second difference is constant, we understand that this type of sequence is not a linear sequence, but it's a quadratic sequence. Okay. So to get it, I just wanna get another. I'll put 2 here. This must also be 2. Then I said 8 plus 2 is 10. So, and then we can also find the 5th term here by doing this. And then we're going to do in other words, we say what minus 20 equals to 10, or 20 plus 10 equal to 30. That's better that way, because 30 minus 20 is 10. That's the first one. Meaning the fifth term, T5 here, what we're looking for is equal to 30. So this is the right answer here. Okay. That was question 1. Then question 2 says determine the number of squares in design N. So in design N, how can we do? Okay, because this is a quadratic pattern. Remember the quadratic pattern that we did in grade 10. In grade 10 is of the form Tn equal to n squared plus c. Okay, this is a constant. Now I look at my patterns as they are. I have 2, 6, 12, 20, 30. So if I change the color, I notice that square numbers are like 1, 4 squares. They are like 1, 4, 9, 16, 25. Those are the squares, okay? So now over here, I have 2. So it means if I have 1, I need to plus a constant to the square number to get 2. Obviously, that constant must be 1. So it must be a 1 here, okay? And then over here, we plus what? We plus 2. There we plus 3. And then we plus 4 to get 20. So that we plus 1 here to get 2. We plus 2 here to get 6. We plus 3 there to get 12. We plus 4 to get 20. Over here also we plus 5 to get 30. Now note that the pattern. It's actually one here. This one here is a square number. Okay? It is like 1 squared. Okay? Let me write it like this is actually 1 squared. Okay? It is like 1 squared. Same as 4. 4 is the square of 2. It's like 2 squared. Same also with 9. That's 3 squared. Okay, 16 also is the square of 4. It's like 4 squared. Same as 25 is the square of 5. So it's 5 squared. Now see, it's like 1 squared plus 1. That's 2. 2 squared plus 2, that's 6. 3 squared plus 3, 4 squared plus 4, 5 squared plus 5. Then we can say that therefore Tn here will be what? N squared plus n. Okay, 1 squared plus 1, 2 squared plus 2, 3 squared plus 3, 4 squared plus 4, 5 squared plus maybe like that all the time. So Tn here will be n squared plus n. Okay, and then question 3 says how many squares are there in design 20? So the 20th design in this list will be like, so basically we're looking for T20, okay? So we're gonna say T20, we're gonna sub wherever we have like n, we sub by 20. So we're gonna sub T20 will be like 20 squared, n squared, so we sub there 20 squared plus 20, okay? And then 20 squared is 400 plus 20, and this means that T20 will be equal to 420, okay? Okay. Well, we have the question says that consider the sequence 2, 5 quarters, 14 over 13, etc. Now the question says determine the nth term. All right, this is quite of an interesting question here. We can do, what can we do here? We want to consider the numbers like, I mean, the patterns that are like 2, 5 quarters, 14 over 13, 1, 22 over 23, 26 over 28, and then 30 over 33. Now, we need to determine the general formula, the nth term. When we look at these numbers, like we can't see any I'll look at the numerator, okay? Because here there's assumed the denominator is 1 here, and then there also the denominator is 1. 1 is like 1 over 1, 2 is like 2 over 1. If I look at this, the constant, there's no constant difference here because this is plus 3 and that plus 9, and there it's negative 13, and it's negative, I mean, it's 21, and there it's 4, and then there it's 4 again. Okay, so we don't really notice a constant difference here. The difference is very changing. Same also the denominator, because here you notice that it's plus 3, there it's plus 9, there it's negative 13 again, and then there 23 minus 1 is positive 22. Okay, there it's 5, and there also another 5. Okay, so the fact that we can see a constant difference at the last year, even at the denominator, we can try to write it in the form that we have like a constant difference for all of these. Okay, for each of these terms of the pattern, I can try to make a denominator the constant difference to be 4. How can I then? You know, we can rewrite these 2 here. This 2 over 1 can be written as, you see, 2 over 1. It can be written as 6 over 3. It can be 4 over 2. Okay, let's say it can be like 4 over 2. Look, if I do 4 over 2, 5 over 4 can be can also be written like, how can I make, because I'm trying to have at the numerator a difference of 4, constant difference of 4. So now, is there a way that I can write 5 over 4 such that from 4 to that number, new number, it's going to be the constant difference will be 4. Let's see. How else can I write 5 over 10? 5 over 4. I can write it as 10 over 8. But from 4 to 10, from this 4 here to 10, it's not the difference will be 6. It's not 4. So even if I increase the number here, it's gonna be it's gonna be more than 4. Now I can write 4 over 2 differently. Okay, instead of writing 4 over 2, I can write it like 6 over 3. Why I'm saying 6 over 3? Because from 6 to 4, the difference will be 4. Okay, here the constant difference here from there to there is going to be plus 4. You see, and then the next number in the pattern is 14 over 13. So here again, the difference will be 4. Also plus 4. And the denominator now, look, from 3 to 8, the denominator is going to be plus 5. Okay, same as over here, the denominator also. It's going to be plus 5, and there also it's going to be plus 5. Now, you notice that's going to be the same for all the terms. Okay, 1 can be written, we can write 1 in different way. I need to write 1, but 1 over 1 here. 1 over 1 can be written, if I need to have a constant difference of 4, I know I'll just already say 14 plus 4, which is 18. So 1 can be written as 18 over 18. You see? So that's with plus 4 also here. And then here 13 to 18 is also plus 5. You see? And then the next term is 22 over 23. So 22 over 23. You see that from 18 to 22 is plus 4. And then 18 to 23 is plus 5. Okay? And then the next step will be 26 over 28. Over here, again, it's plus 4, and there, plus 5. And then also, obviously, for 30 and 33, the difference, as we said, was plus 4 and then plus 5. Now that we have constant difference at the numerator and the denominator, we can write a formula for it. We can say that Tn will be equal to what? For the numerator, we have a constant difference of 4. I can write 4n, okay? And then if we have 4, I need to get 6, the first term here. What can I add to 4 to get 6? I add 2, so I'm going to say 4n plus 2. over, now the denominator, the constant difference was 5, so I write 5n. Okay, I said to myself, if I have 5, I need to get 3, what must I do? I'll minus 2. So I minus 2 here. So this is actually the nth term. Okay. Now, the following question says calculate the 20th term, so T20 in other words. So this means, that's question 2 now. This means from this answer Tn we will substitute wherever we have n, we will substitute by 20. Okay. We sub 20 over here, and then 20 over there, 20. Now this will be T20 will be equal to 82, because that makes 4 times 20 is 80, 80 plus 2 is 82, over 98, because 5 times 20 is 100, 100 minus 2 is 98. This can be simplified. I can see we can simplify by 4. Okay, we can do that. No, not by 4, but by 2, because by 2 it's going to be 41 at the numerator, and then at the denominator by 2 is going to be 44. No, not 44, excuse me. It's going to be 49. So that's T20. So T20 would be 41 over 49. Thank you. Well, the question says, consider the number pattern 1, 3, 1, 6, 1, 9, 1, 12, 1, etc. Determine the 999th term and the 1000th term. Okay. You can notice that this pattern here is like 1, 3, 1. Excuse me. Always like that. So all the odd numbers are 1, and the even numbers has we can say the even term, not the even number, the even term are a linear pattern. Okay, follows a linear pattern, and then the odd terms. Okay, this is like term 1. I can write it like this. This is term 1. That's term 2. That's term 3. That's term 4, etc. So the odd terms are just ones. Okay, they follow that pattern. It's a linear pattern. It's a constant pattern because the constant difference will be 0, and then the even terms follows an arithmetic or linear pattern, because it's like 3, 6, 9. Difference is 3. Now, if I need to find the T999, we do know that this term here, this one is uneven or odd. Okay, therefore this term is just going to be 1. Okay, and then term 1000 will be like in the linear pattern parts, which consists of terms like 3, 6, 9, 12, etc. So over here we can notice that we have a constant difference of 3. Okay, then we can say this will be 3n. Okay, and then let's first find the Tn. Tn here will be 3n, and then minus 2 to get no, not minus 2, but just 3n actually. 3n, because the first term, if I just pull out the even terms from this pattern, so it's going to be like 3n only. Now, if I do that way, T100, I mean 1000, is the same thing as T500 from this new pattern. Okay, so this the T1000 from the main pattern will be equal to T500 from this pattern of even terms. Then this will be written as Tn will be equal to not Tn but T1000 will be T1000 will be equal to 3. Instead of me writing 1000 there, I just want to say 500. Okay, because it is the 500 terms of this pattern. Then this will be equal to 1500. Okay, let me say it over again. To get T100, 1000 I mean, is equal to T500. Why? Because I only select, okay, there are two patterns here. One pattern consists of ones. Okay, the pattern of odd terms consists of one, like 1 here. This is also an odd. Term 3, it's odd, 1. Term 5, it's 1. Term 7, it's 1. And then we also have even terms, like term 2 is 3. Term 4, it's 6. Term 4 is 6. Term 6 is going to be 9. So I put this pattern over here. Now, T1000 in this list is the same thing as T500 in this other list here. So this is why we can sub 500 here, and then we get T1000 equal to 1500. Thank you. Well, we have another question here, question G. The question says SIPO wrote the same name suite over and over again as follows, as we can see there. And then the question says, what is the 23rd letters? Find the 402nd letters, and then etc. Okay, now before I start answering the questions, I'm first gonna write the word suite here. Suite, and then we can notice that the word suite has like 1, 2, 3, 4, 5 letters. Okay, so from here we can build what I can say a general form to repeat the words suite. It's going to be Tn will be equal to 5n. Okay, because after every 5 letters is the first letter of the word suite. Okay, so now question 1. See what is the 23rd letters. Okay, because here I have like, it's like counting in 5. The pattern would be like 5, 10, 15, 20, 25, 30, etc. Okay, so now I know 23rd must be in between 20 and 25. So, or maybe by the 20th. By the 20th, 23rd meaning I need to add 3 to 20. So which letter should be? Because by the 20 here, it means it completes another group of the word suite. So this was the first group, T1, T2, T3, T4. Okay, so plus 3, we count here 1, 2, 3. So E is the 23rd letter. So the 23rd letter will be equal to E. Okay. Now the second question says find the 402nd letter. So some process. I know because we're counting 5, I have like 402. Okay. 402 is not a multiple of 5, but 400 is. So we know that after 400, the 400 letters will be the end of the word suite, and then the first 2 letters will be the first. The remaining 2 will be the first 2 letters of the word suite. Over here, in this case, it's W because you count 1 and 2, it's W. So therefore, the 402nd term letters here, I mean, will be W. Okay. Now question 3 says that find the first W. Excuse me. The first W is in the 2nd position. The second W is in the 7th position. Okay. The third W is the 12th position. And so forth. Determine in what position is the 100th. Okay, it's not shown here, but it was the 100th W. The 100th W. Okay, now in this case, like there is only one W in the word suite. Okay, only one W. Now it means it will follow the same pattern, the same formula. Because if W is here, the first W is here, we count 1, 2, 3, 4, 5. We got W. We count again 1, 2, 3, 4, 5. It's gonna be another W. So it's gonna be always after after 5 letters. So we can say TN here will be 5N. Okay. So now to find the second, I mean the 100th W, we're going to do Tn will be equal to 5n. So 5 multiplied by 100. Okay. I see 5 T100 here, 5 multiplied by 100. But now because the first W is on the second position, we do 5 minus 2. Okay. So this will be 3. So minus, yes, if I have 5, to get the second position, we do 5 minus 2, it's 3. So this is then 500 minus 3, which is equal to 497. Thank you.